Alright, after yesterday's lesson, I discussed all the key concepts that you need to know up to yesterday in terms of the foundation, and also like a recap of what you were taught in grade 9. Okay, so everything I'm doing up to this point is a revision of grade 9 work. If you didn't understand the linear function, this will be your last chance. Okay, but you have to know that it's a very important function, especially in the FET phase, because it comes up throughout the FET phase. So here you are given this graph, right? The graph of F, and F is parallel to G. So the two graphs are parallel, okay, like that. Okay, that means their gradients are equal. Okay, if two straight lines are parallel, their gradients will be equal. Then you also have some points, like here you have got an x-intercept, you've got a y-intercept, we don't know what the value of y here. We have got a y-intercept here, y is 6, the x-intercept, okay, is equal to 9. So the first question says, determine the equation of f, which is this straight line here, right? Now, as you can see, the straight line is slanting to the left, therefore its gradient, when I calculate it, it has to be negative. So if I want to find the equation, I need to determine the gradient first. Okay, I need to determine the gradient first. You cannot find the equation of a straight line without knowing its gradient, right? So I'm going to find the gradient. So for 2.1, I'm going to use this y-intercept and that x-intercept. Okay? The coordinates at the y-intercept are 0, 6. The coordinates at the x-intercept are 9, 0. Okay? It's very important for you to know that along the x-axis, y is 0. Along the x-axis, y is 0. And along the y-axis, x is 0. Okay? So I'll use these 2 points to calculate the gradient. So my gradient is equal to y2 minus y1 over x2 minus x1. Remember, I told you that you can also start with y1 minus y2, x1 minus x2. You get the same result, right? So if I consider the first two coordinates as my y2, so I'll have 6 here minus 0, right? And that is over 0 minus 9. So here I'm saying this is my x2, that's my y2. This is my x1, and that's my y1. Okay, it is your choice. You are the one who has to decide which point you're going to have your x1 and your y1, x2 and y2. Now, before you calculate the gradient, you must have an idea as to whether it's going to be positive or negative. Right? The shape of the line must tell you, okay, by observation. So it is slanting to the left, therefore, when I do the calculation there for the gradient, it has to be a negative gradient. You can't get a positive gradient for a straight line like this. That will be incorrect. Right? So m is going to be 6 over minus 9, which is equal to negative 2 over 3. So that's my gradient, negative 2 over 3. What this means is, if a person is going down 2 units, right, they are moving horizontally by 3 units. That's what that means. So it's more like a person is going down a mountain. Every 2 meters you go down horizontally, you are going 3 meters. That's what this means. Right? Now, once you find the gradient, okay, there are 2 ways to find the equation. Okay? Now I'm going to go to the nature of this class. I have to show you both ways. Right? The first way, which most learners may understand, is to use the general equation of the straight line to determine the equation. So we'll say y equal mx plus c, because most learners won't see that the 6 is the c, okay? But the c is there on the graph. You don't have to calculate it, but not everyone will see that. So you have to use the what? The equation. Then you choose a point along the straight line where you substitute a value of y and a value of x. Okay, you want to calculate c. I'm sure you can understand that it makes sense to not choose a value of y which is 0. Okay, we only have 2 points on the straight line. This point and that point. We don't have another point. So if we are to find the equation using this general equation to determine c, it means I have to put 6 here. Where there is m, I'll put minus 2 over 3. Where there is x, I'm substituting that point. I'll put 0, so I'll get my c. And I'm sure you can see that minus 2 over 3 times 0 gives us a what? A 0. So c is going to be 6, which is the value of y here. Okay? Which you don't have to do that calculation. If you see that there's a y-intercept on the graph, you don't have to calculate c. It's unnecessary. Okay? So what this means is c is going to be 6. Therefore, the equation of this graph is going to be y equal to minus, okay, let me write it properly. It's going to be y equal to minus 2 over 3x plus 6. That's the equation. Okay? Now, you can find this equation by finding the gradient only through a calculation. The c, you can identify it on the graph. Okay? But if it happens that you can't identify the c on the graph, it means that question must give you another point along the straight line. Okay? Where you know an x value and a y value. But for this question, the y-intercept is given, so you don't have to calculate it. But if you can't see it, then you just do this calculation that I did here. Okay? And then I determine that c is equal to 6. Right. But the second method is more by inspection, where you can see that, okay, on my graph, the straight line intersects with the y-axis at this point here, therefore c is equal to 6. Okay, so that will be your equation. Any questions? It's very easy. I expect everyone to be able to do that. And then the next question says the equation of g. Now, to find the equation of g, okay, we know that the two straight lines are parallel. Therefore, their gradients are equal. Which means I don't have to worry myself to calculate the gradient for g. It is equivalent to the gradient of f. So, I'll say mg is equal to mf. Both are equal to minus 2 over 3. Right? But now, for g, I don't know the y-intercept, which means I can't determine the y-intercept by inspection, like in the previous question, where I could easily identify c. Here I can't, which means I need to do a substitution. Okay? And the only point that I can substitute is this point here, where x is minus 6, y is 0. So I'll write my general equation, y equal to mx plus c. Okay? Then where there is y, since I'm substituting this point as the x-intercept, y will be 0. Okay? And my m is negative 2 over 3. My x is negative 6. Then I can calculate c. If you simplify that, you get 0 equal to positive 4 plus c. Right? Common sense must tell you that if this is an intersection point between the line and the y-axis, means the value of C there must be negative because the point is below the x-axis. When you're answering this question, use common sense. Okay? Common sense. So, minus 4 is equal to C. Therefore, the equation is going to be y equal to minus 2 over 3x minus negative 4. So that will be the equation for the line G. Okay. When you're answering the question, also use common sense. You can't get a y-intercept which is positive when the point is below the x-axis. It won't make sense. Right? Any questions there? Yeah, this topic is very important actually. If you can understand it, you're going to find things smooth sailing as we go on. In 2.3, the length of OK. So that's the length from here to there. All right. Can someone tell me the answer? The length. Yes, 4 units. Remember, length is never negative. Length of distance is never negative. In physics, it's called a scalar quantity. It's never negative. You can't say the distance between Devon and PMB is minus 75 kilometers. No, no, no. Distance is never negative. But the good thing is, there is a formula that you can use to calculate it. You can't visualize it, okay? But common sense must tell you if at this point here y is 0, at this point y is minus 4, what is the distance? Distance is 4 units, not negative 4, please. Distance is always positive. And in this class, going forward, I don't expect anybody to write distance as a negative value. Okay? So the length, okay, 4 units. And I'm going to show you a formula to do it. Right? The formula, okay, let me duplicate this page and then I'll show you here. Let me erase this. It's not allowing me to erase. It takes on, then I can do some adjustment. Let me do it here. So let me try to do it there before this change. So 2.3. When you're calculating a vertical distance, right? Because the vertical distance is based on y values, am I right? The horizontal distance is based on x value. So the vertical distance, use the y value. Now, the basic formula for that, right? For vertical distance, it will be d equal to y maximum minus y minimum. You'll never go wrong with that formula. You'll never go wrong. Whenever you're doing questions on graphs, you ask to calculate a distance which is vertical, use that formula. For horizontal, it will be x max minus x minimum. Later, we'll introduce what's called the distance formula. That's when you do analytical geometry. But this formula, it will help you to get the 4 units that Paul spoke about. And you get a positive answer straight away. So let's use it. So the distance of OK, so I'm replacing the D by OK because we want the length of OK. Now, which one is greater? 0 and minus 4? It's 0. So our y max will be 0 minus 4. And this will give you 0 plus 4. And you get 4 units as a positive answer. So if you use this formula here, you'll be able to get the answer as a positive straight away without any issue. And that formula is very important because in the near future you're going to encounter questions where you have to calculate a distance between 2 points on a graph. If it's a vertical distance, then it's a piece of cake. You just use this formula. If it's a horizontal distance, then let me just write it for you. If it's a horizontal distance, right, for horizontal distance it will be d equal to x max minus x minimum. This is for horizontal. Okay. And obviously this is for vertical distances. Okay. So make sure you are aware of that going forward. Right. Any questions?